Well, here we are at the beginning of another chapter. We're in chapter 5. We're going to use properties of exponents to work through some things that we're going to get prepared for the rest of chapter 5. So a lot of review, a lot of stuff you may have seen in Algebra 1 class, but you know what? If it's not reviewed to you, that's okay. We'll work through it together. Scientific notation is the first thing we come upon. Scientific notation, they're numbers like 1.4 times 10 to the 9th, which simply means if I take that 1.4 and I move that decimal place 9 places to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, the decimal place is now at the end, and I just fill all of these up with zeros. We use scientific notation for really big numbers and really small numbers. So if you had something like 2.4 times 10 to the negative 6, well, if we take the 2.4, and if it's going negative direction, it's going to go to the left instead of the right, and I move this 6 places, 1, 2, 3, 4, 5, 6, and now my decimal point is there. You see that's a really small number. So if you're to a positive exponent, it's going to be a big number. If you're to a negative exponent, it's going to be a small number. Let's take a look at some of these properties of exponents that you might remember from previous courses. A to the m times a to the n would be a to the mn. That would be something like 2 to the 3rd times 2 to the 4th is going to be 2 to the 7th power. And I think I wrote this a little wrong here. It should be a to the mn. There should have been a little plus symbol in there. A to the m plus n. The power of powers properties, that's the one where we multiply the m times the n. So if I said 2 to the 3rd to the 4th power, that would be 2 to the 12th. If I take a look at the power of a product property, AB to the m is going to be a to the m, b to the m. That's kind of something like 2x to the 3rd power would be 2 to the 3rd times x to the 3rd. That 3 kind of goes whoop, whoop. And the negative exponent property pushes everything to the bottom. So if you end up with, if you have a to the negative m, that's 1 over a to the m. The zero exponent property, anything in the zero exponent is just 1. So if I said 7 to the 0, that's 1, or 100 to the 0, that's 1. A to the m over a to the n, we subtract these things. And maybe I can make this make more sense with some numbers. If I did something like this, 2 to the 7th over 2 to the 3rd. Well, on the top I have 2, 2, 2, 2, 2, 2, 2. Over, on the bottom I have 2, 2, 2. Anything same top and bottom here? And so as I'm taking a look at all these things being multiplied by each other, somebody might say 2. That's the same. So if I cross 3 from the bottom and 3 from the top, I have 4 2's left. Well, that was 7 minus 3 was 4. And power of a quotient property is a to the m over b to the m. All right. Here's some other number examples. 6 to the 2 to the 3, well, that's going to be 6 to the 2 times 3, or 6 to the 6, or 6 6's. So when you look at 6 times 6 times 6 times 6 times 6 times 6, you're going to get 4 6, 6, 5, 6. And if I take a look at this 4 to the 5 over 4 to the 3, we end up subtracting these things. 4 to the 5 times 4 to the 3. All right, brief break there. So when we do this 4 to the 5th over 4 to the 3rd, well, if you do the 5 minus 3, you get 2. Therefore, you have 4 squared is 16. Remember, like I said with the 2's, you have 4 5s on the top, or 5 4s actually. And on the bottom, you have 3 4s. So you cross out 3 and 3, and you're left with 2 on the top. 7 to the negative 4 would be 1 over 7 to the 4th, which is going to be 1 over 7, 7, 7, 7. Or 1 over 2401. Okay, and you leave that in fraction form. Let's take a look at example 2 here. In example 2, Iceland covers about 1.03 times 10 to the 5th square kilometers and has approximately 2.94 times 10 to the 5th people. What's the population? What's the population per area, right? People per square kilometer. Well, you have 1.03 times 10 to the 5th. Well, you have, it's not the best problem in the world because they use 10 to the 5th and 10 to the 5th. But 1.03 times 10 to the 5th over 2.94 times 10 to the 5th. Well, right away, is there anything same on top and on bottom? 10 to the 5th, 10 to the 5th. Those cancel each other out. And you end up with 1.03. Oh, sorry, that was the square kilometers. You end up with, let's flip these, 2.94 divided by 1.03. And you get 2.85 people per square kilometer, or just about 3 people per square kilometer. Doesn't seem like a lot of people, does it? Let's take a look at example 3 now. In example 3, we take this 3 and go whoop, whoop, and it gets multiplied. So we end up with x to the 15th and y to the 6th. And you ask yourself, are there anything the same, the top and the bottom? Well, I have an x to the 15th on the top and an x to the 15th on the bottom. So all of the x's on top and bottom kind of eliminate each other. So if I cross out those x to the 15ths, I end up with y to the 6th over y to the 8th. Well, y, right? And on the bottom, y. 1, 2, 3, 4, 5, 6, 7, 8 on the bottom. Well, if I take 6 from the top and 6 from the bottom, I end up with 2 left, but make sure you know they're on the bottom. 1 over y squared. So in this situation, you would do 8 minus 6 and get squared. On B, I'm going to take that a to the negative 4 because it's to a negative exponent. I'm going to move it right to the bottom. So I'm going to have 1 over a to the 4th b squared. And that would be my first move that I would make there because it's inside of the parentheses. And then I would take my 2, make sure you know that this is a 4. I would take my 2 and I would square the 1. Well, 1 squared is simply just going to be 1. But I would take the 2 and multiply it by the 4 here and the 2 here and end up with a to the 8th, b to the 4th. 1 over a to the 8th, b to the 4th. Take a moment. You guys do this checkpoint. Give yourself some real time. I know some of you guys have been skirting out on this. Just pause, hit pause, and take a moment to solve these equations. All right, hopefully you did that. We're going to flip this because it's to the negative 1, but I would probably do the things inside the parentheses if they were easy first. So I have 5 8s on the top and 2 8s on the bottom, and I end up with 8 to the 3rd to the negative 1 power. Well, that becomes 8 to the negative third, which becomes 1 over 8 to the third. And that's how I could leave that. 1 over 8 to the third, or 1 over 512. This one here, because that 10 is it's times 10 to the negative 2, this is going to be a small number. This is a fairly big number. What I might do is just call this 4,000, because that's what 10 times 10 to the third would be, times, and now 7 times 10 to the negative 2, watch this, it's 7.0 right now, that's where the decimal is. I'm going to move it back 2 places, and so I'm going to have 0.07. Alright, and then I can multiply those two things together on my calculator and simply get 280. A lot of times we're not going to use 4 times 10 to the third to explain 4,000. 4,000 is much easier. We'd use it for probably bigger numbers than that. Take a look at number 3. I think my first move on number 3 would be to move that y to the negative 6 to the bottom and make it y to the positive 6. And then when you take everything to the 7th power, you end up with x to the 14th, 7 times 2 is 14, and y to the 42nd. All right. Let's take a look at this next one. I might do what's inside the parentheses first. It looks like I have 5 a's on the bottom, 3 a's on top, so I'm going to have a to the third on the bottom. And the b's kind of cancel each other out because there's 1 and 1. So I end up with negative 2 over a to the third, all to the third power. Well, that becomes negative 8, 2 to the third. Negative 2 to the third is negative 8 over a to the 9th. And let's take a look at this one last problem here, this example 4. Example 4 is a real-world problem with a beach ball. Basically, the volume of a beach ball compared to the volume of a baseball. So what is the volume of a beach ball and the volume of a baseball? Well, the radius of a beach ball is 5.6 times greater than the radius of a baseball. So instead of being r as the radius, I'm going to call it 5.6 r. And if I have 5.6 r over r cubed, and I work this whole problem out, the first thing I'll see is that the 4/3 pi eliminates top and bottom. And then I end up with 5.6 to the third power times r to the third power, because I did a little whoop whoop action. And I divided by r cubed. Well, the r cubes eliminate each other. And I end up with 5.6 to the third power. And 5.6 to the third power is 176. Well, it's about 176 times greater. All right. Well, that's the end of 5.1. I hope you found it useful, and have a good